So we have a square roots from negative numbers, negative 25 and square root of negative 81. So that if you have a square root from a negative number, first thing to do to write it in terms of I. Yes, imaginary unit, which is square root of negative 1. Okay, the first number, the first square root can be written as 4 times I times square root of 25. And the second one, I times square root of 81. Both numbers 25 and 81 are perfect squares, so that, yes, the exam reviews on Pearson are optional, yes. So, and then we can take a square root from a non-negative real number without any problem. So 4 times I times 5 minus I times square root of 81 is 9. Then we have 20I minus 9I equals to 11I. So we can work with I as we work with like terms with X, for example, and add or subtract like terms with I. Okay, the difference of squares. Difference of squares. So the formula is a squared minus b squared. Difference of squares equals to a minus b times a plus b. Yes, so here we have squares. We can represent each of the terms as a square. The first as 8x squared. The second is 9 squared. So it can be written as a difference 8x minus 9 times 8x plus 9. That's all. Absolute value inequality equation. Absolute value equation. So absolute value equation, like absolute value of u equals a, it means that u can be either equal to a or u equals negative 8. So one absolute value equation actually includes two normal equations, so that it is equivalent to two equations. Like if absolute value of u equals 5, it means that u can be equal to either to 5 or u can be equal to negative 5. Yes. So it is simple when it is just a number. When we have the whole equation under the absolute value bar, we get two equations. So 4x minus 7 can be equal to 9, or 4x minus 7 can be also equal to negative 9, then the absolute value will be 9. Okay, and we solve both equations. So we add 7 to the left and to the right. 4x equals 16 and divide by 4 on the left and on the right. X equals to 4 is the first solution. And then we solve the second equation on the same way. We add 7 to the left and to the right. 4x equals negative 9 plus 7 is negative 2. And divide by 4 on the left and on the right. X equals to negative 1/2, the second solution. Okay, rational equation. Rational equations, the first thing to do, we should mention that there is a restriction on the domain. So x is not equal to 5 and x is not equal to negative 5. Just in case, if you get an answer 5 or negative 5, we exclude this number from the solution set. Okay, and then we find the less common denominator. Since x squared minus 25 is a difference of squares is the same, it's equal to x minus 5 times x plus 5, then you see that this product includes both denominators from the left-hand side. So the less common denominator is x minus 5 times x plus 5, which is the same as x squared minus 25. Okay, so we multiply the equation by LCD, 4 over x plus 5 multiplied by x minus 5 times x plus 5 plus 2 over x minus 5 multiplied by x minus 5 times x plus 5 equals to 32 over x squared minus 25 multiplied by x minus 5 and by x plus 5. And then we cancel out all the denominators. X plus 5, it cancels with x plus 5 in the numerator, x minus 5 times x minus 5, and x squared minus 25 is cancelled with their product. And what we have left, so 4 times x minus 5 plus 2 times x plus 5, and on the right we have 32. Then we simplify, so we multiply 4 by x minus 5, 4x minus 20 plus 2x plus 2 times 5 plus 10 equals to 32, and combine like terms, 4x and 2x, 6x, negative 20, positive 10, minus 10 equals 32. We add them to the left and to the right. So 6x equals to 42, and we divide by 6 on the left and on the right, so that x equals to 7. 7 is not equal to 5 or to negative 5, so 7 is the solution of this rational equation. Radical equation, and as usual, if you just give an answer, and even if it is a correct answer but no work is shown, or if the shown work doesn't correspond to the answer, then you only get 5 points from 10 for the solution. So it's not so easy to solve such an equation in your head, even for me. So that's why I want to see how you solve it on paper. Okay, a radical equation. To solve a radical equation, we need to square both sides. And remember that when you square an equation, you get extraneous solutions that must be excluded afterward. So if you square the square root, we just cancel the square root. Yes, so square root squared will be 5x minus 24. And we have x squared on the right, so we have a quadratic equation. Let us bring the terms from the left to the right, so we subtract 5x and add 24 to the left and to the right, and get the equation x squared minus 5x plus 24 equals to 0. And the first we will try to find the solution by trial and error. We try to find the numbers that give a product of 24 and sum of 5. Okay, like 8 and 3. 8 and 3 must work here. Let us just check the possibly. So no, they do not work here. Let us change here to plus. Then here will be minus, then 8 and 3 will work. So with 3 with plus and 8 with minus. So that 8 times 3, negative 24, negative 8 plus 3, negative 5. Okay, then we get two solutions, x equal to negative 3 and x equal to 8. And then we must check proposed solutions because we have squared the equation. So one of the solution can be extraneous solution. And actually, you see that negative 3 cannot work anyway, because square root of 5 times negative 3 plus 24 cannot be equal to negative number. Square root is a positive number. Let us check the second one. Square root of 5 times 8 plus 24 equals to 8. 5 times 8 is 40. 40 plus 24 is 64, and square root of 64 equals to 8, and it works. So x equal to 8 is the solution of this equation. Okay, use the graph to find indicated function values. So we want to determine y or x intercept and a couple of points on the graph. So using the graph, okay, the intercept. So there can be several x-intercepts. Here we have two x-intercepts, x equal to -1 and x equal to 1. There is only one y-intercept possible, and here the y-intercept is y equal 3. And let us find the other two values. So f of -2. So x equals -2. This point, we find the corresponding point on the graph, which is -3. And then f of 1. F of 1, so first we take x equal 1 and find the corresponding y value. At that point, y value is 0. So f of 1 is 0. The piecewise function, find 3 of the values of the piecewise function. Here I remind you that although we have two lines in the definition of a piecewise function, we only use one line for every case. So when we want to find f of -3, first we look what condition does it satisfy. So the first condition, x less than 4, the second, x greater than 4. -3 is less than 4. Therefore, we use the first line. the first line, so 5 times x, or 5 times -3, which is -15. F of 0. 0 is also less than 4. Therefore, we use again the first line. 5 times 0 equals 0. And the third line, the third function value, f of 4. 4 doesn't satisfy the first condition, x less than 4. For 4, satisfy the second condition, 4 is greater than or equal than 4. Yes, therefore, we use the second line. The second line, so we use the equation 8 minus x. We substitute 4 for x and get 4 as an answer. An equation of a parallel line. Write an equation for the line passing through the given point and parallel to the line whose equation is y equals -5x plus 3. Okay, the slope is -5, and since the line that we want to determine the equation is parallel, it means that it will have the same slope. We can write the equation of the line in point slope form. Since we know the slope and we know that it passed through the point 2, -6. Therefore, we can use point slope form. Y minus y1 times m slope multiplied by x minus x1. So x1 is the x coordinate of the given point, and y1 is the y coordinate of the given point, and x and y are arbitrary points. Okay, let us substitute. Y minus -6 equals to -5 times x minus 2. Y plus 6 equals -5x, -5 times -2 plus 10, and let us bring 6 to the right. Subtract 6 from the left and from the right, and we get y equals -5x plus 4. Composite function. So we have two functions f of x and g of x, and we want to find f circle g of x. Okay, on the first place we have f. It means that we write f as outside function. We take the function f at the point g of x. So the function f is a square root, but the square root of g of x. Square root of 11 minus x. And we want to determine the value of this function at the point x equal 2. Square root of 11 minus 2, or square root of 9. You can work differently. You can continue differently. You can determine f of g of 2. You can substitute this 2 directly. First find g of 2. F g of 2 is 11 minus 2, which is 9. And then find f of 9, square root of 9, which is 3. Okay, both will work. Okay, and another variation of the same problem when the function f of x is not a root, but just a product. So f circle g means the same f of g of x or f of g of 2. So we first substitute the given number 2 into the inside function. G of 2, 11 minus 2 is 9. And then we find f of 9. 2 times 9 is 18. Quadratic function. Determine whether the function has a minimum value or a maximum value. So the function has a leading coefficient equal to -4. So when the function x squared has a graph, a parabola open upward, negative x squared has a graph open downward. So when leading coefficient is negative, then we have a graph, a parabola open downward. It means we have a top point. The vertex is the upmost point, which is the maximum value. Okay, the function has a maximum value. And this maximum value can be found. So first to find this maximum value, we first must find where it occurs. So we usually use the coordinates for the maximum h and k. For h, we have a formula negative b over 2a, where a is -4 and b is this coefficient, the coefficient at x. So a equals -4, b equals 24. We substitute -24 divided by 2 times -4 and simplify. Negative sign with numerator and in the denominator can cancel out. So we have 24 divided by 2 divided by 4. So we can multiply them. Divided by 8, and 24 divided by 8 is 3. So h equals 3. So the minimum, in our case, the maximum value occurs at x equal 3. And what is this value? The maximum value, it can be found by substituting 3 into the equation of the function f of 3. We must find f of 3. So -4 times 3 squared plus 24 times 3 minus 9. negative 4 times 9 plus 24 times 3 is 72 minus 9, which is 32. I recommend you to use calculator for such small calculation, even though they may look, oh wait a minute, it's not 32. So 72 minus 45, it is 32 minus 5, 27. Okay, it's better to check with the calculator always. Okay, and this is the x value or k h value, and this is the y value. The maximum value is the y value, and it occurs at x value of 3. Okay. A third-degree polynomial function with real coefficients. So if we have the function with real coefficients, then we have some rules about the zeros. For example, if we have a complex zero like 5i, we must have a zero that is complex conjugate. So if 5i is the zero, then we must have another zero which is complex conjugate. It means that we have 1 0 negative 6, the second 0 5i, the third 0 is negative 5i. Now we can write the equation of the function using the theorem that we have studied in the third chapter. So that polynomial function can be represented as coefficient a that we still have to find times the product of 3 factors, since we have a third-degree polynomial function of 3 factors, x minus negative 6 times x minus 5i times x minus negative 5i. X plus 6 times x minus 5i times x plus 5i. So, and this product can be written as a difference of squares. A times x plus 6 times x squared minus 5i squared. So you remember that I squared equals to negative 1, so we can write it as a times x plus 6 times x squared plus 25. Because we have negative sign and I squared is also negative 1, so we usually get plus in such an equation. And now to find the leading coefficient, we can use this extra condition that we have, f of 4 equals 41. We have already found that the equation looks like this. F of x equals a times x plus 6 times x squared plus 25. We actually don't need to multiply them. We can use this form. So, and let us substitute the information that is this additional information that is given here. So substitute x equals 4 into the equation. F of 4 is 41. A is still unknown. 4 plus 6 times 4 squared, 16 plus 25. You see we got an equation with only one unknown. 41 equals A times 10 times 30, 41. 41 equals A times 4, 1, 0. To find A, we want to isolate A on one of the sides of the equation. So we divide by 4, 1, 0 on the left and on the right and get A equal 1/10. So the leading coefficient is 1/10. 8 greater than or equal to 0. We can first we find the boundary values x squared minus 6x plus 8 equals to 0, minus the product equal to 8 minus 2, x minus 4 equal to 0. The product is 8. The sum is negative 6. Okay, we have two boundary points, x equal 2 and x equal 4. And we must test the values. So actually, you don't need to test every interval, but if you want, so let us test x equals 0 from the first interval, 0 minus. We must better test in the original equation. So let us move this. In the original equation, so 0 minus 6 times 0 plus 8, it equals to 8, so greater than 0. So here, positive. We can test 3 for the middle interval. So actually the sign must change on every interval, but you can test it. 3 squared minus 6 times 3 plus 8 equals 9 minus 18. Negative 1 is less than 0, so negative. And you can also test 5 for the third interval and see that it is positive here. So that the question where the polynomial function is greater than or equal to 0. Greater than or equal means we must include boundary points, and the answer will be given with two intervals. Interval from negative infinity to the first point, 2 including 2, and the second interval from 4 including 4 to positive infinity. Find the distance between pair of points. The distance will be given by the formula x1 minus x2 squared plus y1 minus y2 squared, or you can write x2 minus x1, y2 minus y1. Since you square, doesn't matter in what order you write the coordinates. x1, y1, x2, y2. So substitute the values. x1 minus x2, 5 minus 14 squared, y1 minus y2. 7 minus 19 squared. 5 minus 14 is 9 squared. So 5 minus 14 is -9, but since we square, we don't need to write this. We disregard this negative sign. It disappears by squaring. 7 minus 19 is 12 squared. Square root of 81 plus 144. So 225 square root of 225 is 15. So the distance between the point is 15. So and one more. So the next question. So next question. Rewrite the equation in equivalent form. So that two questions from the third exam will be combined together. Some students will get write it logarithmic into exponential, the other write exponential into logarithmic form. So what is important here? First, to determine what is the base. Yes, in logarithmic form, the base is, so it's in exponential form, the base is what we raise to the power x. Yes, in logarithmic form, the base is written as an index by the logarithm. Yes, when you write it in logarithmic form, you write base and a small index by the logarithm sign. And you remember that the logarithm gave you the exponent. So the logarithm must be equal to the exponent x here. So, and then 5 goes as an argument of the logarithm. The base is written as a small index in the logarithmic equation. So, and logarithm is equal to the exponent. So when you write it as an exponential, in an exponential form, you take the base y and raise it to the power given by the exponent, by the value of the logarithm. Y raised to the power 5 equals to 8. The logarithms gives them the exponent to which we must raise y to get 8.